Okay, and we have just seen that our three variables are co-integrated, so we can run the VECM model now, right? Okay, so how to run? I go to statistics, then I go to multivariate time series, then I go to VECM model. You can see from here, right? You can see from here VECM model that I select. Okay, and and our dependent variable is cons, and then EX and GDP are the in independent variable. Actually, this model is our target model, and cons is the dependent variable, and EX and GDP are the independent variables. And the second issue, number of co-integration model or rank, we got one, right, from the Johansen test of co-integration. So I put here one because we have got this result that there is one co-integration model or rank. So here I put 1. And the lag selection, so actually we got 3 lakhs to be chosen, right? 3 lakhs should be used, right? So here I put 4 lakhs because this 4 actually will become 3. So normally this 4 will become 3, right? So that is why I am putting 4, right? I am putting 4 maximum lakh, but actually the whole thing will become 3 lakh, and 3 lakhs have been recommended by the lakh selection criteria, right? That we did previously. And here I keep it constant, right? I keep it constant. Trend specification, I keep it as it is. And anything from here, no. Anything from here, no. Anything from here, no. Everything remain unchanged, right? Then I can proceed. Then I press OK. So that is the VECM model that is coming up gradually, right? This is my models, VECM, right? So it is the models we can see from here, right? Okay, VECM model you can see from here. It start from here actually, right? It start from here. VEC rank, right? Start from here. Not from here. Sorry, it's from here actually. Vector error correction model, it is from here, and you can see we have 3 dependent variable, right? So actually what is happening here, VECM model automatically convert the variable into first difference all the time. Actually, last time we put only cons, we put EX and we put GDP, but these 3 variables automatically has converted into first difference, and that is why it is dcons, it is DEX, and it is DGDP, right? Because we have 3 model. Okay, you can see the dcons. Actually, this one is the dependent variable, and here this is the coefficient. This is standard error. This is Z statistics, and this one is the probability value. So normally coefficient divided by standard error, you can get the Z statistics all the time, and meaning that 1.71 divided by 2.29, you can get 0.75. That will always happen. This divided by this, you can get minus 1.37. That will always happen. Okay, here this decons actually is the dependent variable, and this one, this one, this one, this one, right, all are independent variable, right? And also DEX is the dependent variable, and here all are independent variable, and here DGDP is the dependent variable, and all are independent variable, right? And here actually we have taken 3 lags, right? So here you can see lag 1, lag 2, lag 3, right? But I put four lags maximum, but they have chosen actually 3 lags, and 3 lags actually have been advised, right? And also EX variable has 3 lags, lag 1, lag 2, lag 3, and GDP also has 3 lags, and this is the constant. Okay, so first I talk about this one. What is this one? CE1. What is it? What is CE1, right? Actually this one is called, I can call it error correction term. Error correction term, or I can call it speed of adjustment towards equilibrium. Equilibrium, right? Speed of adjustment towards equilibrium, right? Okay. Okay, now that means this L1 actually is the error correction term, or speed of adjustment towards equilibrium. Okay. Okay, now what is the question? Actually, the first model actually is our target model, meaning that decons actually until this, decons actually our target model. So we shall consider only decons, not other model. That means from here to here we shall only consider, because cons is our dependent variable for this model, right? So we shall concentrate only here, because cons is the dependent variable. Okay. Okay, now there are two issues. One is long run issue, that is issue number 1, long run causality, that is issue number 1. Issue number 2, short run causality, right? That is second issue. Okay, first I talk about long run causality. What is it? Okay. Okay. And it happens only in here, in the CE1, right? Okay. And what is the guideline? If the CE1 is negative in sign, negative in sign and significant, right, then we can say there is a long run causality running from EX and GDP to cons, right? But here you can see the L1, the sign is not negative, it is positive. And also the probability value is 45.4%, meaning that this one is not also significant, meaning that there is no long run causality running from EX and GDP to cons, right? So that is the decision. Okay, now we talk about short run causality. That is our second issue to discuss. Short run causality, right? Okay. Okay, so first I check whether cons, sorry, not cons, because I better take from here, whether export EX can cause cons or not, right? Or I can say whether EX lag 1, EX lag 2 and EX lag 3 jointly can cause cons or not, right? That we want to check now, right? Okay, how to check it? How to check it? So I go to statistics, right? Then I go to the post estimation, right? Then I go to test. Then I go to test linear hypothesis, right? I select here. Okay. Okay, here we select the create. We have to create some specification, right? We have to create some specification. I create. Okay, here I select coefficient in specific equation are 0, and here our e e equation is d cons, right? You can see d cons actually our dependent variable, right? And test this coefficient. So actually we have, first we are testing export, right? So I take 3 lag of export. It is lag 1 of export, it is lag 2 of export, it is the lag 3 of export. You can see we have taken here lag 1, lag 2 and lag 3 export, right? And coefficient in specific equation are 0, meaning that that is the null hypothesis that all these three variable are 0, right? That is the null hypothesis. That is lag 1 x ex, lag 2 ex and lag 3 ex actually is 0, right? So that is the null hypothesis. Okay, then we can check it, we can test this hypothesis, right? Okay, how to test? I bet. Okay, I can put the, sorry, why is the stuff? Sorry, so I lost it. No, it is here. Okay, so we can check it now, right? We can check it now. I press OK, and then I press OK. Okay, here is the hypothesis we set, right? You can check, right? You can see LDEX is 0, 0, 0, right? Right? Okay, and the chi-square value and the probability is this one, right? Okay, and here the null hypothesis, the null is there is no short run causality running from Ex to cons, right? That is our dependent variable. That is the null hypothesis, right? There is no short run causality running from Ex, but Ex has three lag variable, right? Lag 1 and lag 2 and lag 3, right? Right? From lag 1, lag 2, lag 3 to cons. That is our null hypothesis, right? And here our probability is how much? 39.46%, which is more than 5%, meaning that we cannot reject null hypothesis. Rather, we accept null hypothesis, meaning that there is no short-run causality from export to cons. Okay, so that is our first decision. Okay, what about our second decision? That is that we check from our this is our model, right? This is our target model. So we have checked already this Ex. Now we check GDP the same way, whether lag 1 of GDP, lag 2 of GDP, lag 3 of GDP jointly can cause our dependent variable or not. Okay, so as before, I go to statistics, then I go to post estimation, I go to test, I go to linear test linear hypothesis as before. Okay, then I make it reset, right? I select R, meaning that resetting the whole things. Okay, create a new specification. I create. Okay, as before, I select this one, right? I select this one, and our equation is d cons. So that is our target variable or our target model. And here we take the all the GDP data. This is the lag 1 GDP, this is lag 2 GDP, and this is lag 3 GDP, right? And what is the null hypothesis? All these three variables are 0 jointly, right? That is the null hypothesis. Actually, we have set here, right? Okay, then I press OK. Then I press OK. Okay, here you can see. So actually, we set it as before. So actually, what is our null hypothesis? The null hypothesis is there is no short run causality running from GDP lag 1, GDP lag 2 and GDP lag 3 to cons. That is the null hypothesis as before. Okay, and here p value is 21.61%, and that is more than 5%. So we cannot reject null hypothesis. Rather, we accept null hypothesis, meaning that there is also no short-run causality running from GDP to cons. Okay, what is the summary of this model here? Summary is there is no long run or short run causality running from EX and GDP to cons. That is the summary of this model. Okay, now we check diagnostic checking. That means as a whole, how is this VECM model, right? That we can check. Okay, how to check? Okay, I go to statistics, right? I go to statistics, then I go to multivariate time series, then I go to the VEC diagnostic test, right? That I take, and first I check about autocorrelation, right? So first I check autocorrelation. So whether there is a autocorrelation or not, I select it. Okay, maximum order of I put it 2. Even I can put it 1 also. If I put it 1, suppose, then what happens? Suppose I take it 1, only 1. I press OK. Okay, so here I put 1, right? Okay, here when I put 1, not 2, it is the lag 1, right? And it is the null hypothesis that there is no autocorrelation at lag order, right? So here I put lag 1, and probability is what? 4.6%, 4.671%, which is less than 5%, right? Meaning that we can reject our null hypothesis, and that is no autocorrelation. This means our VECM model has autocorrelation as a whole, and that is not desirable. So we are not happy about the model because there is autocorrelation. Okay, then we can do one more test, multivariate. Then I go to multivariate. Then I go to VEC diagnostic. Then I check the test of normality, right? Whether the residuals are normally distributed or not. So here I take only Jarkabera statistics, right? That I check only. Okay, it is coming up. You can see Jarkabera statistics. And what is the null hypothesis? Null is residuals are normally distributed, and that is desirable, right? That is desirable. And here the first model, that is decons, here the probability value is 92.24%, meaning that we cannot reject null hypothesis, rather we accept null hypothesis, meaning that residuals are normally distributed, and that we are happy about it. Okay, and the second model, here also the residuals are normally distributed, and DGDP also residual is normally distributed, and as a whole the p-value is 79.9%, meaning that we cannot reject null hypothesis, rather we accept null hypothesis, right? Meaning that residuals are normally distributed. So we are happy about this model. But this model has only one problem, that there is autocorrelation, right? So we cannot accept the model because there is autocorrelation. So we must do something. We must fix the problem so that autocorrelation problem uh, um, should not come, because autocorrelation problem is a serious problem. Thank you very much for being with me for a while.